Okay, in this video we're going to talk about vertex form of a parabola. It's very similar to what we did last time. It's just since it's written in vertex form, it's easier to find the vertex, as you might expect. So vertex form is written like this: y equals a times x minus h squared plus k. As opposed to standard form, which was ax squared plus bx plus c. So you can see the difference between the two here. In this case, the vertex is at the point h comma k. The vertex is at the point h comma k, and so you can see you can find those really easily just by looking at the graph. The a value is the same in both cases, but in vertex form, the vertex is easily accessible. So if the vertex is at the point h comma k, then the axis of symmetry is at the line x equals h. So let's use that to graph this example that we have up here. So in this, a is equal to negative 0.5, h is equal to 2, and k is equal to 3. Remember, vertex form is a times x minus h squared plus k. So this minus h, this is already in the x minus form, so that's why h is 2 and not negative 2. And then plus k, so it's plus 3. If this had been y equals negative 0.5 x plus 2 squared plus 3, then I would need to rewrite this in vertex form, which has x minus h, so negative 0.5 x minus negative 2. That's the same thing as x plus 2, but now it's written in the form x minus plus k. And so you can see here h is negative 2. So if you have a plus in there, then h is negative. And if you have a minus in there, then h is positive. Alright, so let's erase this. So we have our a, our h, and our k values. So we can write our vertex. Our vertex is at the point h comma k, which is 2 comma 3, 1, 2, 1, 2, 3. Our a is negative 0.5, so that means we're going down. And let's just go ahead and let's sketch the axis of symmetry. I'm not going to use the line tool this time. And then let's pick a point on either side. So when x is 0, what is y? When x is 0, negative, I'm going to write it as 1/2 instead of 0.5. 0 minus 2 squared plus 3. So y is equal to negative 1/2 times negative 2 squared plus 3. I don't know why I wrote plus twice. Y is equal to negative 1/2 times 4, because negative 2 times negative 2 is a positive 4. Negative 1/2 times 4 is a negative 2, so y is equal to 1. So when x is 0, y is 1. Still, all parabolas are symmetric, so if I go over 2 more, I have the point on the other side. And then let's plug in, what about when x equals negative 1? Let's do when x equals negative 1. So give me some space on here, and let's plug in negative 1. Y is equal to negative 1/2 times negative 1, that's the x value that I just plugged in, minus 2 squared plus 3 is equal to negative 1/2 minus 3 squared plus 3. Negative 3 squared is negative 3 times negative 3, so it's a positive 9. 9 times negative 1/2 is negative 9 over 2 plus 3. Another way to write this is negative 4.5 plus 3, and that's equal to negative 1.5. So we have the point negative 1, negative 1.5. That's also on the graph. If I go over 1, 2, 3 to the axis of symmetry, and then over 1, 2, 3 again, I have this point, and now I have both sides of my parabola. So that's the graph of it. The vertex is a lot easier to find, and then you just plug in points on either side and evaluate. Okay, kind of the converse of what we just did is finding the equation given the vertex and one point. Well, vertex form is y equals a times x minus h squared plus k, and the vertex is at the point h comma k. So if the vertex is 3, 4, then the value for h is 3 and the value for k is 4. So that means we can come in here and plug in for h and k the h value and the k value. So we almost have the equation now. All we have left is to find this a value. And the way you find the a value is you plug in your x and your y pair from the other point. So this is x comma y. So if I plug that in for y and x, I can solve for a. So I'm going to do that. Y is negative 4. We don't know what a is. X is 5. And now if I solve this for a, I'll have my a value. Negative 4 equals a times 2 squared plus 4. So negative 4 is equal to a times 4 plus 4. If I subtract 4 from both sides, I'm going to write over here, I'm running out of space. I get negative 8 on the left side is equal to 4 times a, or a times 4 on the right side. So that makes, if I divide both of these by 4, I get a equals negative 2. So now I can plug that back in over here. Let me erase all these lines and squiggles and crazy stuff. Alright, so I had a is equal to x minus 3 squared plus 4. Now I know my a value, so I can just plug that in. So here's my equation of this graph. So I plugged in the 3 and the 4 from my vertex, that's my h and my k, and I used my point to plug in for x and y to find my a value. Okay, and now last we're going to switch from standard form to vertex form. Standard form, oh, I wrote 2, is y equals ax squared plus bx plus c. And the vertex for standard form is at the point negative b over 2a, comma f of negative b over 2a. This is what we did in the last lesson. So if you find the vertex, you can rewrite this in vertex form. Vertex form is y equals a times x minus h squared plus k. If we find h and k, then we can plug those in here, and the a value is going to be the same. So the a value in this case is 2. So our vertex form is 2 times x minus h squared plus k. And now we need to find what is h and k. H is going to be this value, negative b over 2a. So let's find that. Negative b, b is 10, over 2a, a is 2, is equal to negative 10 over 4, which is negative 5 over 2, or you could write it as a decimal, negative 2.5. So I'm going to plug in negative 2.5 for h now. Y is equal to 2 times x minus h. And I got to find k. K is what we get when we plug negative 2.5 back into this equation. So I'm going to come up here and erase this to give myself some space. And I'm going to use negative 5 over 2. I'm going to plug that back in for x. Negative 5 over 2 squared plus 10 times negative 5 over 2 plus 7. And you get y equals 2 times 25 over 4 plus negative 50 over 2, which is also known as 25. So I could have, instead of multiplying that out, this is 10. 10 and 2 cancel out and leave me with 5. 5 times negative 5 is negative 25 plus 7. So y is equal to 2 and the 4 cancel, and I'm left with 25 over 2, which is 12 and a half, plus negative 25 plus 7. Negative 25 plus 12 and a half is negative 12 and a half, plus 7 gives you a negative 5 and a half. So that is our k value, negative 5.5. So I plugged that in for k here. So now I've got 8a was just the same as the a value here. X was negative b over 2a, which, I mean not x, h was negative b over 2a, which turned out to be negative 2.5. And k was what we got when we evaluated this algebraic expression for x equals negative 2.5. And this is what we get. I'm going to write that in red a little bit nicer. over here. So that's y equals 2 times x. X minus negative 2.5 is the same thing as x plus 2.5. And then plus k, which is negative 5.5. So instead of writing plus, I should write minus. So y equals 2 times x plus 2.5 squared minus 5.5. And that is the exact same equation. It's the same graph as this equation up here. They're equivalent, but it's written in vertex form.